So today we talk about chapter 5, trigonometric identity equation. Okay. So first of all, you should know what's the identity. I think we already done chapter 4. If you give a sine or cosine, whatever, and you can find other 5 rest of them, the degree or value, right? So trigonometric identity. So identity that involve the trigonometric function. So we have reciprocal identity, upside down, right? So sine is 1 over cosecant, right? Cosine 1 over secant. Tangent 1 over cotangent. I think you do it, right? And cosecant, so secant will be 1 over sine, cosecant, right? And secant 1 over cosine. Cotangent will be 1 over tangent. Also, quotient identity, this also probably know it. The tangent will be sine over cosine, and cotangent upside down, right? So cosine over sine. Nothing new, right? We already done before, right? Okay, maybe question using reciprocal or quotient identity. So two questions. A, they given cosecant theta will be 7 or 4. Find the sine. Second question. Okay, maybe one by one. First of all, cosecant theta will be 7 or 4. Find the sine theta. Okay, so we already know sine, right? Theta equal 1 over cosecant. So which is this one 1 over 7 over 4, which is 4 over 7. Okay, pretty simple, right? But second question, cotangent, the given value, find the sine. And the given sine too, sorry, and cosine. Alright, we apply in here, right? Which means cosine x will be sine theta, sine x over tangent x. But they give a cotangent, so which is sine x. Cotangent will be here 1 over tangent, so it will be just times cotangent x, right? So sine x squared to 5 over 3 and times cotangent 2 over 5 square root 5. So 5 square root 5 cancel, and 2 over 15. Okay, that's pretty simple too, right? Question? It'll be okay, right? Alright, move to the next one. So you should try the below this question, guide practice 1A, 1B, right? Yourself. Alright, Pythagorean theorem, using Pythagorean theorem identity. So first of all, how did you get to this one? From here, right? So cosine and sine and 1. These two sides, and this one 90 degree, right? Hypotenuse the 1, each side sine cosine. So we already know if you C, right? C and A and B. How can I do that? A square, B square will be C square, right? So apply here. So sine square, cosine square, 1 square, right? So sine x theta square, cosine theta square, will be 1 square. Right? That's why they said Pythagorean theorem, Pythagorean identity. Alright, how about tangent plus 1 secant square? This one's simple, right? Because tangent, how can you make it? Just thinking about tangent theta equal, we know that sine theta over cosine theta, right? This idea. So first of all, tangent theta. How can I make it? Sine over cosine. So we from here just divide all like cosine theta square theta divide all here, which means sine theta square over cosine square plus, how about here, cosine square over cosine square, right? And then equal to 1 over what? Cosine square. So this one going to be what? Tangent theta square, right? This one going to be 1. This one over cosine means secant, right? So secant theta square. Boom, 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 right? How about this one? Think about this way. How can you make a cotangent? Cotangent means what? Cosine theta over sine theta, right? So we just defined from here all sine theta square, not cosine this time, sine theta square, okay? Which means sine theta square over sine theta square plus cosine theta square over sine theta square equal to 1 over sine theta square. So which means first one going to be 1, right? So 1 plus cosine over sine will be cotangent square theta. 1 over sine will be cosecant theta square. Something like that. Okay. So this one we call Pythagorean identity. We should memorize or understand. So also my way, I just memorize one formula, this one, pretty simple because using Pythagorean theorem, and apply that and that, and then come out all 3 formula. Do you understand? Right? But if you don't know, you have no choice, just to memorize. Sorry about that. Okay, maybe try one problem, last one today. Okay, so how can you do that? They given tangent theta negative 8, sine is positive, find sine and cosine. Okay, so we should know which quadrant they're talking about, or just number simply. So how can you find it? So using do you remember Pythagorean identity? So we know sine and cosine, sine and cosecant, because they give us a tangent value, which means tangent theta zeta squared plus 1 equal secant square, right? So using that, so how can you do that? Negative 8 square plus 1 equal to secant zeta square. Okay, this one 65 secant zeta square. So secant zeta plus minus square root 65. So cosine, we are looking cosine, right? Cosine zeta will be 1 over plus minus square root 65, which means plus minus square root 65 over 65. Okay, right? And we are looking for sine. So sine, we know tangent zeta will be sine zeta over cosine zeta, right? So cosine zeta sine zeta over tangent zeta. So sine zeta, how much will be? No, sorry. You should be sine. Oh, oops. Let me erase that. Sorry about that. We already find the cosine. Wait, do one more time. Alright. So, sine zeta will be tangent zeta times cosine zeta, right? So tangent is negative 8, cosine plus minus square root 65 over 65, which is plus minus. We should define the plus minus. There are two things here. Tangent negative, which means quadrant. We know that all students take calculus, right? So this one negative means quadrant 2 and 4. Sine is positive, supposed to be 2. Okay, so quadrant 2. So they're talking about quadrant 2. Quadrant 2 means cosine will be negative, right? So answer will be cosine zeta negative 65 over 65, right? So this one's supposed to be negative, right? Let me change it. Okay. So here here negative, so make positive, right? So 8 square root 65 over 65. Okay, I think it's done. So make sure, first of all, tangent negative, sine positive will be quadrant 2. So we should looking for answer quadrant 2. Okay, quadrant 2. So find the cosine first using Pythagorean identity. So cosine will 2 value, but we should take negative value. And then plug in identity, we got the sine positive. Alright, maybe okay? Alright, and next page, I think that's it. Alright, from today that's it. If you have a question, let me know, right? You can talk to me. Alright, so see you tomorrow. Bye bye.